Hey guys, welcome to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2012, 10A, Problem 18, and it deals with geometry. I hope you all enjoy this video and let's get started. The problem states the closed curve in the figure is made up of 9 congruent circular arcs, each of length 2 pi over 3, where each of the centers of the corresponding circles is among the vertices of a regular hexagon of side 2. What is the area enclosed by the curve? Okay, so I connected the vertices of the regular hexagon, so now it looks like this. And so to start off the problem, we are going to find out the area of the hexagon first. So to find out the area of a regular hexagon, we need the formula, which is 3 times radical 3 over 2 times s squared, where s is the side length. And it tells us that the side length is 2, so that means that the area would be 3 times radical 3 over 2 times 4. Simplifying this, we would get 6 times radical 3. And also, because it says that the side of the regular hexagon is 2, that means that each side would be 1. And this is because the arcs are congruent, so that means that all of the lengths are congruent, and so it would tell us that this length and this length is the same, so it would be 1 and 1 on each. But with that aside, you can solve this now that you have the area of the regular hexagon. You can solve it by subtracting the area of the arcs and then adding them back together, but I'm gonna do it another way. So it says that all of the arcs are congruent. So that means that what if we quote unquote cut this arc and place this arc right here? So that means that this arc is gone and it is placed right here to fill in this spot. And then do that same thing with this side. And so both of these arcs would not exist anymore and they are placed in the spot right here. And then we have one right here, so we can just take another arc. And so get rid of this one and then place it right here. And I'm doing this because, as I said, all of the arcs are congruent. And it wants us to solve the area enclosed by the curve. So if you place these arcs in these spots, then you are still solving the problem. Because it's not like we are adding extra arc or anything. We're just simply taking the arcs that we need to add their area to and placing them on a different spot. And this makes everything easier because now we don't have to subtract anything from the area of the hexagon because we have filled in all the empty places of the hexagon. So that means that we have 6 radical 3. And then we have to add the remaining 3 arcs that we did not add to solve for the area enclosed by the curve. So that means that we need to solve for arc 1, 2, and 3. Well, as I said, that we already know that the radius is 1. And so that means that the circumference of a circle is 2 pi. And this is because the formula for the circumference of a circle is 2 times pi times r squared. And we know that r is the radius and we know the radius is 1. So it would just be 2 times pi times 1, which is 2 pi. And then it also tells us one more very important information is that the length of each circular arc is 2 pi over 3. And so if you look at the relationship between the circumference of the whole circle, 2 pi, and 2 pi over 3, we see that each arc is a third of the whole circle. So if we multiply the length of one of the arcs times 30, then we would get 2 pi. And so therefore, we now know that if you add up the area of 3 arcs, then that means we would get pi r squared, which is the area of a circle. And perfectly, we have 3 arcs that we need to solve the area for. And so we don't even need to solve for each of the arcs and then add them together, because we already know that the sum of the area of the 3 arcs is equal to pi r squared. So that means that we can just add pi r squared. We see that if we look at the answer choices, we don't have a 6 radical 30 plus pi r squared, and that's because we need to get rid of the r squared, because r we already know is radius, which is 1, so it would just be pi plus 6 times radical 3. And so therefore the answer is E.